Welcome to Chapter 6, Crypt Analysis and Code Breaking. Exciting chapter. So what we're going to cover today. We're going to be looking at what is crypt analysis, the Enigma machine, what is code breaking, methods to code break, how to break a code message, and what makes code breaking easier. They're general topics. So basically, as you know, changing ciphertext into plain text without the use of a key. We're going to reverse the engineering of the algorithms and the key, and it's used to identify weaknesses and flaws for developers. So sometimes what happens is you'll create a algorithm that puts in a ciphertext, takes the plain text, ciphers it, and you want to see how good it is. So you would have another department or another person or even hire a third party to break it, to see how if it is breakable. And that's what we're trying to get to. You know, how good is the cipher that you put together? Is it breakable? So in World War II, there were a couple of things that we had in the cryptology area. First, we had the Navajo code talkers. They were a small group of, we had the Navajo code talkers. It was a small group of people. They would go out in the advanced areas of the war, and they would use their code to talk. They would use their native language to talk. And because there were such a small number of them, that no one knew their actual language. So it allowed them to transmit information over airwaves, and if the Japanese received them, they would know what they were saying, because the Navajo language was so minor in the world that very few people knew it, and unless you were another Navajo, you wouldn't be able to crack it. So that was an important part of the war, that they were able to talk openly, but no one would be able to talk to them unless they were another Navajo. It's actually a good movie on that too. I think it's called Wind Talkers. There's only a few people that understood the language. So then you also had the Germans that talked about the Enigma machine, and I'm going to go through that in a second, also a little more detail. But they pretty much thought it was unbreakable. They had such a secure thing in their thing. They were pretty more sure it was unbreakable. But the Allies created a team called Ultra, and the Allies, and this was over in Bletchley Park, and they worked on cracking that code, cracking the Germans' code. So this is what it looked like. We saw a video of it not too long ago. We'll see another one in a second. But it is a symmetric cipher. Use substitution methods. So you'd hit the letter A, and it would come up as a letter C or D or an X, however. And it had 3 interchange rotors, which you can't really see. They're right in this area. And they were changed out. I think they would be supplied with about 5 or 6 of them, and they'd say, put this rotor in, put that rotor in, put it in this place, blah, blah, blah. So it had that. You also had this front end that said, all right, when this would come through as a B, change it to a D. So you had 2 things that were creating your encryption. And this is why the Germans felt it was unbreakable. So here's a short video on how it actually worked. So why was this important? Because this was the first full-blown effort that we had code breaking. You know, prior to this, during the other wars or whatever, yes, you always had someone. But this was a 9,000 person commitment to break the code of what was going on. So we have different types of, we have a transposition cipher. And that basically just means the plain text letters are rearranged into different configuration. Then we have the substitute decipher, which replaces the character in the original message with new characters, and that's what the Enigma was doing for us, for the Germans actually. And this allowed them to have a secure that they didn't have to worry about it being hacked or being broken. So what are some methods for looking for? How did they go about this? They were looking for keywords. Repeated patterns indicated a short key. So if you watched in the video, they were saying weather report. Well, they knew in every transmission they were transmitting the word weather report or Heil Hitler. And so what they would do is they would find that pattern, and they'd start trying to break just just the word weather report. And they would look at trying to figure out what was the best way to attack to get rid of that so they can break the key. So some basic patterns, if you're looking at a word, if it's a single letter or a word by itself, it was either A or I. If it was two words, you know one would have to be a vowel, or two-letter words, one would be a vowel, one would be a consonant. And if it was a three-letter word, it was always usually he or that or the. And this allowed us to break it. And then you had the frequency. Every language has a letter that are used for, most often in the US language, it's R, S, T, L, and N. So if you're doing a frequency, you could always say, hey, these are the top ones that we'd be using. So that just allowed code breakers, this is just some of the patterns that code breakers are going to be using to figure out what is in the message. So what types of attacks are there? Well, here's a list that we're going to go through. These are the most common ones. We'll look at each one. Brute force, dictionary, frequency, ciphertext only, known plain text, chosen plain text, rainbow, birthday, implementation, timing, and people attacks. So we'll just go through these real quick so you have an idea of the different types of attacks that are out there that are being used today. And most of these are still being used. So what is a brute force attack? Trying all possible key combinations. Two factors, cost and time. Again, Moore's law, where everything doubles in 18 months, and it's measured in milliseconds per year, MIPS. But basically, all this is doing is you have a program that's looking at the data, and it's breaking it into trying to figure out the password by using known patterns. The dictionary attack is used against password files or hash values. It hashes common words and passwords combinations to retain collision on the password hash. So if you remember what we used about hash, it's a fixed length. So if you have a 128-bit hash file, it's 32 characters. So someone would then go around, put in all the possible words in the dictionary, turn them into hash files. So if you used an actual word, it would be in there and someone would get into your password. Frequency analysis. In this attack, the attacker has the advantage of knowing the characteristics of the plain text language. So basically, they're looking for words or which ones are used the most frequently. And as we said, it would be R and T and L and N. So are they always in there? Then you could start to figure out what the word is. Knowing the frequency of certain letters or prediction patterns, such as QU, makes the job of crypt analysis much easier. Ciphertext only. In ciphertext only attack, we assume the attacker has samples of the encrypted text, but may not know the algorithm key or system, but they know what the ciphertext looks like, and they're going to try to decipher it. This is the most difficult attack since the crypt analysis has the least amount of information to work with. Plain text. the attacker has both plain text and ciphertext. The attacker uses analysis to try to determine the key or crypto variable being used. So this one just means that they have what it looked like before and after, or a sample of what it looked like, maybe not the exact file, because if you had the exact file, you're there already. But then they would try to look for patterns in the plain text and ciphertext and how did they come about. Chosen attacks. Plain text, you have the crypto system and the ciphertext. And you're trying to figure out the variables and see how you're going to be able to put it together. The rainbow table, basically it's a hashes and reduction. Combating rainbow tables with special scalable architect, graphic processing, and compute device. Yeah. So a birthday attack. Used to find weaknesses based on your birthday paradox. Birthday paradox states that there's a 50% chance that 2 out of a group of 23 will have the same birthday, not using the year. Increase the group to 60 and the chances are up to 99%. For the math challenge, we are betting that one of them has the same birthday. And this allows us to use that information. Poorly implemented systems or algorithms, such as the weakness in the WEP due to implementation of a small 4. So this is just something if we didn't implement it right and we want to make sure what's going on. Timing and power analysis. Attacks are based on measuring the exact execution times and power consumptions of a chip while encrypting. Measuring this time to indicate the length and the time the algorithm is in use. Side channels and differential power analysis. This is looking at the actual chips and when they're actually working and how long they're taking. People attacks. This is still very common in one of the easiest ways. What are some examples of it? Social engineering. Someone will call you up at work and say, hey, I'm from IT, we're having an issue, I need your login and password, and they give it to them. This is something where we have to train employees to understand that social engineering happens, and we can't let our employees give out information. Purchase key attack. This is bribery or extortion. Someone will get something on you, and you'll see this in the movies all the time. They'll do something that they need. And rubber hose attack is just the assault. So someone's going to beat you up for your login and password. So what did we do? We covered what is cryptos analysis, and it's the code breaking. It is. We spent the first half of the class. How do we code information? How do we put it in, encrypt it? Well, this half we're going to look at how we break that encryption. The enigma, the importance of it. Here the Germans felt that this was an unbreakable machine, and yet the Allies figured out systematically how we can go about breaking this unbreakable machine, and they had success, and it changed the war. What is code breaking? Turning ciphertext, understanding what it is. And we went through the different methods of it. Looking for patterns, right? We said looking for patterns. If it's one word or one letter, it's usually A or I. If it's 2, it's usually a letter and a consonant. If it's 3, it's usually that and and. And we went over all the different types of attack that could happen. So that was this week, chapter 6. Thank you, and have a good day.